that one of the missiles into a rocket, which was known as V2 rocket. From this, I can recall one of the facts that the first rocket which was built was not in America. It was in Russia. It was not in China. It was in India. So, and the inventor was Tipu Sultan. We know him, right? So Tipu Sultan built the rocket motors for the very first time. That's the solid propulsion system. He used those motors in wars. Britishers came. Then Tipu Sultan defeated Britishers in one of the wars. Then Britishers took that technology to the UK, and then they got it patented. So they own the patent for the solid motors right now. So basically, rocket science started in India, but unfortunately, the advancement happened in other countries, and they took the benefit out of it. Uh, so Cold War was happening at that time, and then later on, what happened? The first satellite was launched by Soviets, and it was known as Sputnik 1. And then the John F. Kennedy announced the moon mission. They wanted to show that they can go beyond the low Earth orbit, and they were not planning for something that was high Earth orbit, but they was planning for the directly to the moon. So Apollo was a series of the mission that was conducted by the Americans, and Apollo 11 landed on moon, and we got the first human who stepped into the another world, that is Neil Armstrong. So this is how the space technology era actually started with an intention of competition. There was no intention of innovations. There was no intention of doing business out of it. It just started as an intention to compete with the other countries. But meanwhile, India was not having any space program in those days. UN organized a conference to give the parking slots for the satellites. So what are the parking slots? You cannot put your satellite anywhere in the space. Each and every countries have been given a particular parking slot where you can put your satellite. So at that time, they were giving it for the free of cost to each and every country. And scientists from every country were going to attend that conference, but no one was there from India. But there was a research scientist from ISC who decided to attend it. He saw that news in the newspaper, and we all know him. He is called the father of Indian space expedition. He is Dr. Vikram Sarabhai sir. So Vikram Sarabhai sir decided to attend it. Now in that conference, America asked for 2 parking slots. Russia also asked for 2 parking slots. China asked for 1, and Japan also asked for 1. How many parking slots India asked for? 5. Why?
Okay.
The reason was the parking slots were given for free, and Vikram Sarabhai was a Gujarati.
Mhm.
And we Gujarati are businessmen, so anything that we get for free, of course, we don't leave it, right?
Okay.
So, so he asked for 5 parking slots, and on the very next day, there was a article that was published in New York Times and it showed a picture of few scientists sitting in the laboratory and an Indian farmer at their doorstep knocking their doors, and they wrote in the headlines that India, without having any satellite building capacity, have taken 5 parking slots. What are they going to do? But exactly, just 3 years back, India launched 104 satellites in a single launch on PSLV C-34. And out of that 104 satellites, 99 satellites were American satellites, and they were using our parking slots.
Yes.
So you can imagine that how much visionary Vikram Sarabhai sir was, because he knew that in future, right now they are using it for the competition, but in future they are going to use it for the applications,
Yes.
space applications.
Yes. Yes.
And that is how he incubated ISRO, and ISRO became the first and the only company and organization in the world in those times to use space for the commercial purpose.
Okay.
So while other countries were using it for war, but we were using it for the commercial purpose, and that is how Indian space expedition started. Now we'll talk about the rockets and
How
the current.
commercial? How commercial?
So they were using it for the fishermen. So they launched a few satellite called InSat series. They had GSAT series. They used to give data to the fishermen so that they can directly go to that place and they can catch the fish. They were giving data to the farmers as well for the agricultural purpose, and then they also started Doordarshan, the first educational based channel in India that was started in those times. So this is how they were using space for the commercial purpose and for the real life application. And even he gave the statement that we should be second to none in the in the terms of space application. So this is all what happened. Then in after 2000 or 2001, an era of private space companies started, but we'll get into that later on. Now let's focus on the current technology that we have and we are building, like for the space education and for the students who want to get into this domain. You cannot directly go and directly build a launch vehicle. You need to start from a scrap. You need to start experiment out things at a very small scale. You can afford making mistakes at very small scale. You can try out model rockets, high powered rockets, because they are not so expensive. You can get guidance very easily in our country for that. So let's start talking about that. So first question that should come in our mind is, uh, getting some weird voice. Hello.
I request everyone to mute your
क्या है ये?
तेरे फोन की प्रॉब्लम है साले.
Yes, now you can.
फोन की क्या प्रॉब्लम है?
We'll fight later on.
Yeah.
Okay. मैं तुझे थोड़ी देर बाद कॉल करता हूँ.
Okay.
Okay.
So I'll show you an interesting slide.
क्या बहन चो
Okay, no.
क्या हो रहा है?
मतलब
Yes.
Okay.
Go.
Okay. So what I was telling. So let's start about the rocket technology. So we all know there can be different definitions for the rockets. So generally in my sessions I keep it interactive, but this is something video conference, and it would be very difficult if everyone will start their audio and it will be disturbing. So I'll keep it less interactive right now. I'll give you the direct definitions and what things are included into that. So rockets have multiple definitions. Like some people call it a transportation vehicle to space. Some people call it a cargo vehicle that can take a satellite or space telescopes to space. It's a vehicle for humans as well to travel to space. One of the most interesting definition that I got from a school student was that he said that it is an explosive, it is a bomb. This explosion is under control and unidirectional. Right. So what happens is basically the fuel is ignited, right? An explosion occurs. The explosion is unidirectional and it is under control. Right. So that is what we can call a rocket. Now the question is, on what principle it works, right? And we all have studied it works on the Newton's third law of motion, right? Whenever I ask a student on what principle,
not singly on third law, it applies both three of them: Newton's first law, second law, third law.
Correct. So if you talk about the basics, if you talk about it, and it works on Newton's, so it works on the law of conservation of momentum. For example, if there is a balloon, right? If you blow air in balloon, if you release it, so what will happen? The air will come out at particular velocity. That is what we call exhaust velocity. That will push balloon in the opposite direction, and that is what we call lift-off velocity, right? So and again the force is called thrust. The same thing happens with rockets. So what happens is rockets have the chemicals and the fuels inside it. When we ignite it, the combustion happens and the pressure inside the chamber, it increases. Now that pressure is released in a particular direction, and that generates the force on the rocket body and rocket structure that lifts it up. So this is how basically a rockets work. So now if we talk about the categories of rockets, the rockets are particularly divided into four categories. One is model rocket, second is high powered rocket, third is sounding rocket, and fourth is launch vehicle. So model rockets are generally the toy rockets, the small rockets which anyone can try out at their home and they can build and launch. It contains no metallic parts, it have no flight computers, it have no ejection mechanisms. It's just a rocket structure with a rocket propulsion system and a recovery system. That's a parachute, that's it. Then comes high powered rocket. High powered rockets are the advanced version of the model rockets, but they contain the flight computers inside it. They are heavier in weight when compared to the model rockets. It can weigh up to around 1 kg to 1.5 kg. They can go at the altitude of 400 meters to 800 meters, and they have the flight computers for the data recording, for the live data transmission, for giving the command for the parachute ejections. So it is an advanced version of the model rockets. Then comes sounding rockets. Now sounding rockets are the research-based rockets which can go to space and it can also deploy your satellite into the orbit. Then comes launch vehicles. Launch vehicle does the same, but they are the commercial version of sounding rocket. For example, if I build a car, right, and as a final year project, Now I can travel in that car anywhere in the world, right? So that is what I can call a sounding car. But if I get it commercialized, standard version of it, if everyone in the world in world can buy that car, then I will call it an actual product, right? Same thing as with rockets. Sounding rockets are research-based rockets. They are not commercialized, right? When you commercialize a sounding rocket, they become a launch vehicle, and they are the launch vehicle as standard design. Sounding rockets cannot be a standard design. Every time something new adds on, you remove few things from it because it's purely research-based. So these are the four categories of the rockets. Now we already talked about the working principle. Now we'll talk about the basic structure of a rocket. I have shared you the presentation. Have you shared it with students?
I have not yet shared with them. I will share with them.
Okay,
You want
perfectly
right
fine.
now to share?
No, it's completely fine. I can show it here on the screen.
Okay.
Fine.
Okay.
Is it visible?
You can keep your mobile landscape so it can visible to everyone.
Okay, fine. So there's no issue. I'll talk directly then. The rocket. Let's talk about the rocket subsystems and the rocket structure. What all things are included in a rocket, right? And I'll be specifically focusing on the model rockets and the high-powered rockets. So in rockets, generally we have the topmost portion. We have the nose cone that is pointed. Then we have another section called the body tube, and then we have fins. Now this body tube is further divided into four parts. The topmost portion of the body tube is for the payloads, right? And payloads, what is a payload exactly? So payload is any scientific instrument that you need to carry. It can be a satellite, it can be a camera, it can be any sensors, it can be your altimeters, right? So any instrument that you carry to accomplish your primary mission, that becomes your payload. So for example, if you go to your college in a bus, then for bus you are a payload. If you carry a bag, for you, your bag is a payload. And if your bag contains books, then for your bag, your books are the payloads. Any primary thing that you carry becomes a payload. Right? Then you have the recovery system, you know, part where you put your parachutes and other recovery systems. Like it can be so now to deploy parachute, you have to use multiple mechanism. It can be a mechanical system, it can be an explosive, or anything that you want to use. So you can put your pyros, you can put your non-pyro mechanisms in that particular section. Then comes the flight computer zone. So that's what we call avionics bay. Avionics means aviation plus electronics. So any electronics used in aviation, it's called avionics. And avionics bay is a portion where you put your flight computers, your batteries, and the power systems, your sensors. Like even it includes the communication models, navigation models, everything there. And then comes the rocket motor, right? So we'll get into rocket propulsion system in details later on. Right? So there are multiple shapes of the nose cone that are possible. Someone use parabolic shape, some use ogive shape. We have triangular shapes, spherical shapes. It completely depends on your application, that what shape you want to use. And generally people are using ogive shape. So what happens is, if you go for a triangular nose cone, the air drag will be less, but it won't be able to cut the air in such a way that the air pressure area in around the body, it won't be very less. So the whole structure will experience a very high pressure, and that results into high skin friction. So the rocket's velocity will reduce. If you go for a spherical nose cone, it will spread. Hello.
Go ahead. Go ahead.
Okay, so if you use a spherical nose cone, what happens is it can spread the air in a wider section, but it itself will generate a drag. So what they did, they combined spherical with a triangular shape that is called an ogive shape. Ogive shape spreads the air in a convenient way, and it also reduces the air skin friction. So the rocket can move smoothly and swiftly in air after the launch. So this is why they use generally ogive shapes in all the launch vehicles as well. And then comes the payload section. If you talk about fins, so fins can have multiple shapes. So you can see we have a rectangular, delta swept, tapered swept, then delta. Then we have curved, trapezoidal. So multiple shapes of the fins are also possible. But if you know the real reason why we attach pins, you will come to know which shape to use, and that will cover later on. Basically, three types of rocket propulsion systems are used in a rocket. One is solid motor, right? Second one is liquid engines. Third is hybrid. So now, why we call? So what are these? Rocket motors, and what are the rocket engines? What is the difference between them? Can anyone tell me?
I think we can finish the session, then we will ask the question because they
Okay, perfectly fine. Okay, cool. So the rocket motors, whenever you are dealing with the solid propellant, right? Whenever you are dealing with a static propulsion system, you call it motors. You might have heard that during the launch of PSLV, they have the strap-on motors attached. Why they are called strap-on motors? Because they are solid propelled tanks, right? And they are solid propelled propulsion system. So whenever you are dealing with solid propellant or a static engine, which does not have any moving parts, we call them motors, right? Then comes engines. Engines are the propulsion system with dynamic parts, which have turbo pumps, which have valves, which are moving, right? So any moving part we use in any propulsion system, we call them engine. And generally, liquid propelled propulsion systems have those moving parts, so we call liquid propelled engines. Then come hybrid engine. It's a combination of solid and liquid. They take a PVC pipe or a rubber tube. They pass a nitrogen gas through it, and that is in a controlled manner. And then they ignite it, and that generates a thrust. But so now let me tell you, in high-powered rockets and the modern rockets, only the solid motors are used. Liquids are not used. Why? Because these rockets are very small in size, and you have the weight constraints. You cannot go for the liquid engines because you need to put an oxidizer tank, you need to put a propellant tank, you need to have the pressure tanks, you need to have turbo pumps, you need to have chamber, you need to have nozzles. So many things on a single rocket, on a high powered rocket, it's not possible to put. So they use a solid motor. Solid motor is just a chamber plus nozzle, fine, and you fill up the propellant inside it, and then you can just ignite and you can launch it. So complications are less, they're less expensive, the performance is better than the liquid engine, right? Hybrid engines have the same complexity as the liquid engines, and the performance is very low. So generally, hybrid engines are never used in any high-powered rockets. Then let's talk about the most important thing, and that is the stability parameters. So any rocket, when you fly them, you expect it to have a stable flight. And to ensure that you will have a stable flight, you need to have some prerequisites to keep in mind. There are two prerequisites and two criteria to design a rocket, a stable rocket. One is the center of mass, and the second one is center of pressure. So what is center of mass? Any object, whether it is regular or irregular in shape, whether it is symmetric or asymmetric in shape, have a particular point on it where you can stabilize it, right? Where the complete mass of the object is focused or concentrated on. If you throw that object in air, that object will rotate on that particular point, and that's what we call the center of mass of that object, right? So now it's very easy to find the center of mass of that particular rocket, and I guess we are getting questions, but I'll answer those questions later on. So hold your questions right now, fine? So now center of mass, how to find them? So it's very easy. You just need to draw your rocket. So I have sent the presentation to Christian. He will share it with you later on, and you can just go to that slide. You will come in. You get an idea that how to find that. So what you need to do is draw a rocket, draw a reference line behind it at a particular distance. I'll show you. So this is the rocket I have drawn. We have a reference line here. So is it visible?
Yes, it is visible. Yes.
Okay. It's very simple to find it. What you need to do is first find out the mass of the nose cone, multiply it with the distance from the reference line. So mass of the nose cone multiplied by distance of the nose cone from the reference line. Mass of the body tube multiplied by distance of the body tube from the reference line. If you have put a payload, mass of the payload multiplied by distance of the payload. Mass of the recovery system into distance of the recovery system. Mass of pins into distance. So take the mass of each and every object, multiply it with its distance from the reference line, and divided by the total mass of the rocket. So it's a summation of the mass of an object multiplied with its distance from the reference line divided by the total mass of the rocket. So you will get a particular value, like you got 15 centimeters. So 15 centimeter from where? From nose cone or from the bottom? So 15 centimeter from the reference line will be your center of mass. Fine. If you don't want to get into this complications, this is what NASA uses for their high-powered rockets and the sounding rockets. If you don't want to get into this thing, what you need to do is you need to build your rocket, tie it with a string. The point on at which the rocket remains stable, so will be the center of mass. Got it? So that is how you can find your center of mass. The second point is center of pressure. So what is center of pressure? Now so when your rocket is launched, when it is in the active flight mode, air try to exert pressure on each and every component of the rockets, right? Nose cone, the body tube, the fins, and each and every components. So the pressure is generated, and where the area is more, right? Where the area is more air will strike to that object, right? For example, if you have a aerodynamic shape, then the less air will strike. But if you have a square shape like this, the more air will strike here, right? So, excuse me, you need to find out the center of pressure, that at what point the pressure of the complete air is focused on, and the similar equation is used to find it. It's area. So in previous equation we used mass of an object, and this will take area of nose cone multiply by distance of nose cone from reference line, area of body tube multiply by distance of body tube from reference line, area of fins multiply by distance of fins. We are not considering area of payload or recovery system or the rocket motors. Why? Because they are kept inside the rocket, and air exerts pressure only on the outer structure. So we need to consider only outer structure, and we have to divide this equation by the total area of the rocket. So now what will happen is that you will get a particular point which is called the center of pressure. It will be at some specific distance. Now you have three possibilities. One is center of pressure on the top, and center of gravity or center of mass at the bottom. Second possibility is center of pressure and center of gravity both in the center. And the third one is center of pressure. In first is center of gravity is on the top, center of pressure is at the bottom. And second one is both are in the center. And the third one is center of pressure is on top, and center of gravity is at the bottom. So which one is stable? The answer for this is the first one, where the center of gravity is on top and center of pressure is in the bottom, right? So when the center of gravity is on top and the center of pressure is in the bottom, so you will get a specific value, that is what we call calipers. So now imagine you tie a stone with a string. If you rotate it and if just leave it, right, what will happen is it will go in a tangential motion. The stone will remain at the in the front, and the thread will be at the back side. Right? So it is a law of physics that the center of mass always remains in the direction of the motion, and center of pressure remains at the back. So as we need to launch rockets in upward direction, we need to put the center of the high mass at the top and the low and the center of pressure at the back. So what we do is, that is why all the satellites, all the payloads, all the sensors are kept at the top of the rocket, and the center of gravity is shifted to the top. And to shift the center of pressure in the downward direction, we attach fins. Due to fins, the area increases, and as area increases in the bottom part of the rocket, the center of pressure gets shifted there. So that this is how you get it, the stable rocket. Now there is a unit which we use for the stability. That's what we call caliper. And how to find the caliber? If someone asks you how much stable your rocket is, so you cannot tell them that it's very stable. So what you need to do is say you need to give a particular parameter or the unit to present it. So it's very simple. It's center of gravity center of distance between center of gravity and center of pressure divided by the distance, diameter of the tube. So 2 points, distance between 2 points, and the diameter of the body tube that you used. From that you can get the calibers. according to the National Association of Rocketry and the Triple Houston, these are the two clubs in USA, you need to have minimum 2 caliber of rocket to fly. But in India, we suggest you to fly up to the rocket up with a caliber of 4, because in India we have a very crowded place and there are a lot of buildings. So if your rocket enters someone's home, you will be out of your home. So you need to take care and you need to fly a rocket with the caliber of 4 or more than that, right? And the last thing is what softwares we use. We generally use SpaceCAD and the Open Rocket to design it. So what we do is we design our rockets in the Open Rocket and SpaceCAD. Once the complete design is finalized, we give it to our designing department, which design it in the AutoCAD, and then we get it 3D printed. So we use cardboard and PLA, both materials there. We also use few metallic parts in our high powered rockets. We build our flight computers in house. We have a very high performance flight computers we can generate 30 plus data about the altitude and other things within a second, and we can get 1000 plus data of the total flight. We can take the doubts about the propulsion system in the questions because it's a long topic to discuss on, and we generally use the rocket candy propellant, that is a mixture of potassium nitrate, sugar, and sulfur. And about the rocket motor casing, we have got it manufactured from an industry, and it's a special fiber plus limestone tube that we are using, and it's something which we are going for a patent because it's a new kind of material that we are using it, because it can sustain a temperature up to 300 degrees Celsius. It is lighter in weight and it have a good strength. So chamber pressure, if it increases, still it can bear that pressure and it can give you high thrust. So this is what we are using. And two softwares, as I said, the SpaceCAD and Open Rocket are the basics one that you need to start on. So that's it from my side. Now let's take the questions. Your audio is off, Kishan.
Anyone having doubt, you can ask now to Sunny and Kabrawala.
Getting questions in the bottom section, but I was not able to read them. I was getting distracted.
People have asked questions.
I guess we have got questions. Okay. Could you please share PPT? I have already shared the presentation.
Okay.
Liquid is for upper stage, that is secondary to Leo, but in atmosphere the efficient performance was delivered by solid. We all know that. Okay. High coefficient drag with a conical. I cannot get this point of this liquid is for upper stage. So in generally PSLV they use solid as well in the third or fourth stage. I don't remember it, but they are using in the upper stage as well. So it depends on the application generally. So it's not fixed. You cannot fix it out that you will be using a solid propelled thing or a liquid propelled thing just as a standard thing. It depends purely on your applications, that what kind of flight you want. For example, if you talk about the New Shepard rocket of the Blue Origin, they are using a solid motor for that ejection sets. So it depends, and few are using going for the liquid ejection sets. So it completely depends on your application and even your budget.
Anyone is having any doubt?
Good morning, sir. I have a question.
What kind of fuel we use in boosters?
You're talking about solid boosters?
Yeah, the boosters which are there in the side of the
okay. So they generally use hyper-terminated polybutadiene, that is HTPB. ISRO is using that. Other industries are using ACPC, that's ammonium perchlorate. And there is one more fuel mixture that Reliance Industries are right now working on.
P-ban also?
Sorry?
P-ban.
Hello?
P-ban. Solid propellant.
You're not audible.
I'm saying that can we use P-ban in the boosters?
So it, again, as I said, that it depends how it, because generally you need to keep one thing in your mind, that is the ISP of the propellant, and the highest ISP you can get right now at the very standard environment is HTPV. So generally they are using it. If you are talking about the high powered rockets, you cannot use even HTPV or APCP because it is banned in India right now to be used for any private thing. So you need to just use rocket candy propellants. We are right now planning to get into the liquid engine as well, but it's not allowed in India to do.
There is a one question from one student. Can you tell some
Sir, please
examples
see
of
the chat
igniters?
box. We have put the
Yeah.
questions in chat box.
Some examples of igniters. He is asking about igniters.
Okay. Igniters, if you so for the high powered rockets, we generally use nichrome wire and an ignition circuit that we have made Bluetooth controlled, and you can even go for the steel wool. That is what we use to clean our utensils. So you can go for the steel wool or nichrome wire. Nichrome wires of the very high gauge are a bit expensive, but if you go for the steel wool, it's not so expensive and it's very cheaper. So you can go for that. How to get
Hydrogen
started
also
with
can be used, right?
how to get started with model rocket. Rajvansh have written how to get started with the model rockets. First thing is so model rockets. For that you can just buy motors from US. Estes motors, you can buy them. You can make the a small cardboard structure. I can share a handbook to on making this model rockets. So you can learn from it. You can start with a wooden nose cone or a 3D printed nose cone. You can have just a body tube without any recovery system. Just put the rocket motor. You can launch it. Uh, but I suggest you not to go beyond the high altitude of 100 meters for the model rockets because they are small rockets, and once it go beyond, it will be difficult for you to acquire back safely. So
Okay,